Hello, in this video I'm going to talk to you about rhombi and squares. Rhombi is just the plural of rhombus. You wouldn't say rhombuses, you'd say rhombi. But in layman's terms, a rhombus is just a parallelogram with four congruent sides because all the other properties of a parallelogram apply to a rhombus. So in 6.3 and 6.4 we talked about parallelograms and rectangles, okay? And so a parallelogram has opposite sides that are parallel and congruent. A parallelogram has opposite angles that are congruent. They have consecutive angles that are supplementary, and their diagonals bisect each other. Now you have two additional properties. Those were all properties of parallelograms. These two are new for rhombi, sorry. And so a rhombus is a parallelogram with diagonals that are perpendicular to one another. So remember, that means their diagonals will make a right angle when they intersect. Okay, so here I have a diagonal, here I have a diagonal, and so if they're perpendicular to one another, they make a right angle. And then the diagonals bisect a pair of opposite angles. Okay, so if they bisect the angles, that means they're cutting them in half. So that means like this angle over here be congruent to that one over there. And then opposite angles are congruent, so it'd be like that, and you'd have this situation going on there. Okay, so let's do some examples. The diagonals of a rhombus FG, HJ intersect at K. These are given information to find each measure or value. So if measure of FJH is 82, FJH is 82, find KHJ. So FJH is the big angle, alright? So it's this big angle. Actually, it's better if I trace it like this. Okay, so that's 82. Find KHJ. Alright. So we got KHJ here. Now, so if I were to just poorly draw this rhombus, we know that opposite angles are congruent. So I'm going to put 82 here and 82 there. Now this is a four-sided figure, and so you'll have to recall from 6.1 that four-sided figures, the sum of the interior angles is 360 degrees. So 360 degrees minus 82, I'm going to show my work over here. So 82 plus 82 is 164, so 360 minus 164 is 196. And so that says 196 is these two angles here, which are congruent to one another. So I'm going to cut 196 in half, and I get 98 degrees. Now, I could have done this actually an easier way. This is maybe a more holistic approach, but remember this property right here, consecutive angles are supplementary. So if I'm looking at 82 and this angle here, they have to add up to 180. So I could have just done 180 minus 82, and I get 98. So either way you want to think about it, you get the same answer, okay? Alright, so if GH is x plus 9 and JH is 5x minus 2, find x. Okay, so I'm given two side lengths, and remember a rhombus has all four sides congruent. So I'm just going to set these equal to each other and solve. I'm going to go x plus 9 equals 5x minus 2. Alright, so I can add 2 over, and then I can minus x over. So this is adding 2, that cancels. That cancels. I got 11 equals 4x. So divide by 4, and I get, what is that, 2.25? No, 2.75, sorry. So x equals 2.75. And that's it for that example. Let's look at the next one. Okay, the diagonals of a rhombus, WXYZ, intersect at V. Use the given information to find each measure value. Okay, measure of angle WZX is 37.5. Find ZYX. So WZX, let's trace that. W to Z to X. Alright. Look for ZYX. So I want to know Z, Y, well, let's grab a marker. ZYX. Okay. So, what do I have? I have a tiny angle, and I'm looking for a big angle. It would be more helpful to me if I knew what WZY was. And really, you just got to know that the diagonals bisect a pair of opposite angles, meaning if WZX is 39.5, then WZY is, I'm just going to double that. So 39.5 times 2 is 79. And so what that helps me figure out is if this big angle was 79, I'm looking for this big angle right here. I just need to do that 180 minus 79 because they're supplementary rule. So that's 101. So the answer is 101 degrees. If WX equals 8x minus 5 and WZ equals 6x plus 3, it doesn't matter if one's on the top and one's on the side, they're equal to each other. So 8x minus 5 equals 6x plus 3. So let's do this and let's combine the steps. This is minusing, so I'll add it over there. So I'll subtract this over here. So I get my x is gone on that side, my number's gone on that side, so I'm left with 2x equals 8. So divide by 2, and I get 4. And if it said find the side length, I'd plug it back in, but it doesn't. So I'll just keep going. Let's talk about squares. A square is a parallelogram with 4 congruent sides and 4 right angles. Okay, so remember, a parallelogram with 4 right angles is also a rectangle, but not all 4 sides are the same thing. So a parallelogram that's both a rectangle and a rhombus is a square. So it's kind of the combination of the two, because a rhombus has all 4 sides the same. A rectangle has all 4 angles the same, so that's why it's like it's combining a rhombus and a rectangle. So we have this Venn diagram down here, and it's basically combining the properties, what I just said. The rectangles you see On the left, 4 right angles, 4 congruent angles. A rhombi on the right, rhombus, I don't know. That's 4 congruent sides. So squares combine those two properties. Okay, so you need to know that for a square. Now, there's a couple other properties. So, all other properties of parallelograms, rectangles, and rhombi apply to squares. And then you also have this. Oh no, wait. I'll just be repeating myself. That's what I've been talking about. Those two. A square is also a rectangle because it's parallelogram, 4 right angles. And a square is also a rhombus because it's a parallelogram, 4 congruent sides. So, example 3. Classify this special quadrilateral, explain your reasoning. I'm just going to walk you through these notes. This is not a square because, or a rectangle, because not all angles are congruent. You have opposite angles that are congruent, so I know it's a parallelogram. And then I see that 2 sides are the same, and so I can say that it's probably a rhombus because I can probably conclude that these are opposite each other, because if it's a parallelogram, then the opposite sides are congruent, and if 2 of these are already marked, then you know the other 2 are going to be congruent. So that's why I wrote must be a rhombus. Example 6, I got my numbering wrong, no big deal. Solve a real world problem. It says, you are building a case with glass shelves for collectibles. Given the shelf measurements in the diagram, can you assume that the shelf is a square? Explain. So I have all 4 sides the same. So my gut instinct is to say yes, but this explanation down here is important. You can't assume it's a square because you don't know if all the angles are 90 degrees. You don't know if the diagonals are congruent. So the next one says, you measure the diagonals and find they're both 33.94 inches. What can you conclude about the shape? Yeah, now I can conclude that the diagonals are congruent because it's a square. Now I can conclude it's a square because the diagonals are congruent. Okay, so if I were to do any other math problems like this on a square, it'd all be the same thing, except maybe if I were doing angle ones, I just know that each angle in the corners has to be 90 degrees. But I know all the sides are congruent, and I know that the diagonals, are congruent on a square. So remember that diagonals bisect each other on all the other types of parallelograms? Well, if I draw like a perfect X in a square, I know that they're traveling the same distance across. So that's why you know the diagonals of a square are congruent. So when I say I'm bisecting, that means at this point here, this is equal to this. But with the square, that's also true, but this whole line is congruent to this whole line, whereas in the other shapes, parallelograms, rhombus, rhombi, rectangles, you can't conclude that this long shape is congruent, or this long diagonal is congruent to the other diagonal. You just know that they're bisected. That's why I marked them with different dashes. But here, with the square, I could mark 1 dash here, 1 dash there, 1 dash there, 1 dash there, because they're all the same length, because the square has 4 even sides. So that's about as much as I can say about a square. That's it for 6.5 notes. Hope this helped. Thanks.